This is an exam type question. We have been asked to prove that the DEF is a straight line. To prove that the DEF is a straight line using vectors, we need to show that either of these three cases is true. For example, then DE parallel to the EF, or then DF parallel to the DE vector, or then DF vector parallel to the EF vector, because these have a common point. So if the vectors have the same direction and they have a common point, then they lie on the same straight line. So we start the method by showing the first case, the DE vector parallel to the EF vector. So we need to find the vector DE and the vector EF. Using the method of addition of vectors, we have the vector DE as the sum of these two vectors. Then DC plus the CE. The triangle rule. And therefore, the DE vector is the EF vector is the sum of the vector EC plus the CF. Therefore, the EF vector is changing the sign of the vector CE because it goes opposite direction. We have 5b minus 2a. This is opposite direction of the vector CE and the CF. So the vector EF is 2a minus b. Now, two vectors are parallel only if they can be expressed as multiples of each other. So we try to express the vector DE as a multiple of the EF. So let's check and find the scale factor. The 8a minus 4b is equal to 4 bracket 2a minus b. Therefore, this is the vector DE and this is the vector EF. So we have proved that the vector DE is 4 times the vector EF. And this completes the proof that the DE is parallel to the EF vector. And because these two vectors have the same direction, they are parallel, and they have a common point, the common point is the E, it shows that the points, then DEF is a straight line. The points DEF lie on a straight line. The common point is the E. This is the lesson for today. If you like the lesson, don't forget to subscribe to see more lessons like this one. Thank you.